NASA is delaying the release of data. I said to them in response that this shutdown and the delay is not a sign of extraterrestrial intelligence, but more a sign of terrestrial stupidity.
In the middle of a quiet monitoring cycle, one of NASA's most closely watched comets suddenly vanished. Within minutes, alarms lit up observatories around the world. 3I Atlas had disappeared from every telescope on Earth. The sun had just fired a coronal mass ejection straight into the path of the only known interstellar comet, a violent ambush from one star into the relic of another. Now, scientists are asking a question no one thought they'd ever need to ask. What exactly did we just trigger? The signal that went silent.
3I Atlas was discovered on July 1st by the NASA-funded Atlas survey.
It started like any other monitoring cycle. NASA's Deep Space Network was tracking a known object, one they had been watching for weeks, the third ever confirmed interstellar object to pass through our solar system, 3I Atlas. The signal wasn't just a ping, it was a steady stream of data filled with spectral readings, dust composition, plasma interactions, and light curves. This was history unfolding live, and every telescope from Mauna Kea to the James Webb Space Telescope was quietly feeding information into the same global pipeline.
4 images, this is a brand new near-Earth asteroid.
Scientists weren't expecting fireworks, they were expecting data. And then, in the middle of the night, something changed. The stream went from stable to erratic. The tail of the comet suddenly flared like a broken flashlight, then total silence. It wasn't a mechanical error, but rather something else entirely. 3I Atlas had vanished from sensors. Within 20 minutes, cross-channel alerts went out. At Jet Propulsion Laboratory, multiple real-time feeds were flashing red. Not just one observatory, all of them. And the weirdest part? There was no sign of fragmentation, nor expected light echo. It was like someone had pulled the curtain shut mid-show. By sunrise, the silence had a name. They called it the anomaly. The violent moment, the ambush nobody predicted.
We'll pick out objects that are moving inside of the 4 frames, and we have to identify if they are real or if they are false detections.
No one had seen it coming, but the sun had fired a weapon. 3 days earlier, our star had released a coronal mass ejection, a violent burst of plasma and magnetic field, moving at over 1,000 miles per second. Scientists had flagged it as one of the strongest ejections of this solar cycle. Most of the energy missed Earth completely. It looked harmless, but it was not harmless for 3I Atlas. By sheer cosmic timing, the comet's path through the inner solar system had lined up with the projected trajectory of the solar blast. A direct hit, a 1 in 1,000 alignment, plasma against alien ice, sunfire crashing into something from another star system. This wasn't theoretical anymore. The timestamps matched. The moment the comet's signal vanished aligned perfectly with the predicted impact time of the CME. 3I Atlas didn't just passively drift into the blast, it was ambushed by it. Solar eruptions hit comets all the time, but not during solar maximum, not when the object in question is already unstable and venting unknown gases, and never before with something not native to our solar system.
We have to better understand how active this object is, and then we can refine the size estimate and get a good idea.
In a cosmic sense, this was an experiment no one intended. Plasma against interstellar material, and something reacted. New images processed 18 hours after impact showed an eerie change. The green coma that had once wrapped around the comet's nucleus was gone, replaced by streaks of chaotic debris. The tail had twisted, and the light signature had fractured. It was no longer behaving like a comet. It was behaving like something damaged. Astronomers called it unprecedented. Not because the comet broke up, because comets break up all the time, but because of the way it happened. It was violent, sudden and targeted. Now, if something this powerful, this alien, could be changed by one wave of solar energy, then we were watching something more than a solar event. NASA's emergency response, panic in the data room. The next morning, NASA entered emergency protocol. This wasn't for public broadcast, just a high-priority internal session marked urgent, with every planetary scientist and deep space observer told to stop what they were doing and report to the virtual table. The focus was all on 3I Atlas. The call was allegedly led by a veteran in planetary defense and one of the few voices in the agency known for staying calm, even in chaos. 3I Atlas had just taken a hit that no one forecasted, from a CME that no one expected to be this destructive. Solar eruptions weren't new, but a direct, unfiltered collision with a high-speed interstellar object was a first. And it wasn't just about the hit. It was about the aftermath. Every monitoring system showed instability. The object's nucleus had likely fractured. the coma collapsed. Ionized gases in its trail had scattered in a way no one could model. The composition data suddenly stopped making sense. Its reflective signature had shifted. The chatter inside the meeting room started escalating. The entire planetary defense framework, built to spot objects on a collision course with Earth, wasn't designed to predict or understand how foreign material would respond to our star.
It is only the third time we have detected an object that has come from beyond our solar system.
For decades, astronomers believed they had a decent grasp on solar events and comet interactions, but this wasn't even close to those models. They pulled up comparison data from comet Enki, which had experienced tail disconnection during past solar storms. But that was a slow unraveling. 3I Atlas had experienced an outright collapse. If this object, made of alien material, could violently destabilize from a single wave of plasma, what else could? Could other objects react this way? And were we overlooking similar patterns in the past? The alien comet, the damage, the bigger fear. 3I Atlas was fast and retrograde, coming in at a wild angle, cutting across the solar system at nearly 100,000 miles per hour. From the beginning, scientists had already confirmed it didn't come from our star system. This was the third confirmed interstellar object after Oumuamua and Borisov. But unlike Oumuamua, which passed silently and refused to emit gas or dust, 3I Atlas was an active comet. It was venting materials from the beginning. Its coma had glowed green, rich with diatomic carbon, and its tail had developed fast. That made it special, because it was the first time an object from another star passed through our solar system during solar maximum, which made what happened even more terrifying.
We've only discovered less than 40% of the 90% of the object we need to discover.
The impact didn't just break the comet, it scrambled its chemistry. Spectrographs showed signs of rapid composition changes. Some wavelengths had entirely disappeared. Others appeared in erratic pulses. It was like watching a live system break and then reboot into something else. But the bigger fear was that this wasn't just physical damage. It might have been a reaction. One theory put forward, cautiously, by Dr. Stephen Burns, a physicist from MIT, raised eyebrows during the second day of NASA's internal briefings. He suggested that plasma interactions with alien material could produce effects we've never seen, that the solar event may have acted like a probe, waking up or disrupting chemical states trapped inside the object since its formation. He compared it to cracking open a sealed container from another world. What came out? We don't know. What was destroyed? We don't fully understand. But it happened at a scale we weren't ready for.
The physical makeup of an object tells us about its capability, its impact potential. What can it do on the Earth?
The scary part is that 3I Atlas was supposed to fly by Earth safely. It wasn't considered a threat. It was an opportunity to study alien material from a safe distance. But that assumption depended on the idea that it would behave like comets we've seen before. Instead, the sun touched it, and it broke apart. And if something from another star can destabilize this quickly just from contact with our sun's plasma, then the idea of cosmic safety has to be rewritten. Not just for Earth, but for every spacecraft, every probe, every future mission that might one day rely on flying past these objects for science. This was supposed to be a peaceful flyby, but something just violently ambushed 3I Atlas. And we're only beginning to understand how deep that hit really went. The damage. When plasma meets alien ice. The moment the coronal mass ejection made contact with 3I Atlas, something subtle but significant changed. There was no Hollywood-style explosion nor visible impact crater. But for scientists monitoring the interstellar comet, the signs of stress were undeniable. The tail began to ripple and twist in a way that didn't match any solar wind model. The color shifted, growing erratic, and then dimmed. For a moment, astronomers thought it might be a glitch, but it wasn't. The plasma had hit. A coronal mass ejection is a massive burst of solar plasma, threaded with magnetic fields. When these high-energy particles slam into an object, especially one made of volatile materials like ice and gas, the effects can be unpredictable. On Earth, they cause auroras and disrupt satellites. On a comet like 3I Atlas, especially one from outside our solar system, they might do much more.
The satellite detects the gamma ray burst and it sends a message down to the ground.
Comets are fragile. Most are loosely packed balls of dust, rock, and frozen gases, often described as dirty snowballs. When these materials are exposed to extreme heat or energy, they can rapidly sublimate or even fracture. That's what scientists believe may have happened here. Within 48 hours of the coronal mass ejection impact, 3I Atlas began to behave strangely. Its coma, the glowing cloud of gas and dust that surrounds the nucleus, grew irregular. Telescopes recorded it pulsing, fading, and then flaring back up again. That alone was enough to raise eyebrows. But then came the real surprise. A secondary tail appeared, pointed not away from the sun as expected, but off to the side. That suggested the comet had released something new, possibly jets of gas that were never meant to activate this early, or fragments from a fractured layer deep beneath its surface. 3I Atlas wasn't near any massive object, and the solar heat at that distance shouldn't have been enough to cause this level of activity. The only new variable was the CME, the idea that solar plasma could have seeped into the cracks of a comet, heated its core unevenly, and triggered volatile jets. That's not science fiction. It's exactly what researchers now think they're seeing, and the implications are massive. This is the first time we've ever seen an interstellar object from another star system react to a solar event from our own sun.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth.
It's like pouring a strange liquid into a machine and waiting to see what catches fire. Whatever chemistry built 3I Atlas billions of years ago happened under different conditions than our own solar system. Different radiation, different temperatures, different materials. Now that object is here, and we've just hit it with one of the most powerful forces in our part of the galaxy. No wonder things are acting strange. Some researchers think the coronal mass ejection may have triggered a cascade, melting surface ices that exposed deeper layers, releasing trapped gases, even shifting the comet's spin. A few observatories reported changes in the light curve, suggesting a possible wobble or rotation change. Others noted sudden outbursts of cyanogen and diatomic carbon, chemicals that give comets their eerie green glow.
Green glowing comet is going to make its closest approach to the Earth next Tuesday.
It wasn't total destruction. That's important. 3I Atlas is still intact, but something inside it changed, and that's almost more unsettling. A shift without shattering means there's a deeper process happening below the surface. What we do know is that there's no obvious debris field. That already disproves some of the more dramatic theories floating around online. There's no missing fragments or lost chunks drifting in space. Whatever happened, it stayed contained for now. The comet is still on its path, still moving fast, still being watched by nearly every major observatory on Earth. But it's not the same object it was a week ago. It's been touched, altered, and stressed. The bigger fear, the data. We couldn't see. 3I Atlas got hit without warning, and that's what has scientists more worried than anything else. Every single solar event, from a minor flare to a massive coronal mass ejection, leaves a trail. They begin at the sun's surface, burst outward with measurable energy, and move at predictable speeds. And yet, this one, the coronal mass ejection that slammed into 3I Atlas, wasn't on anyone's radar until it had already landed. That should be impossible. At first, the explanation was timing. Maybe the coronal mass ejection came from a region of the sun we weren't watching closely. But that theory fell apart fast. The sun's Earth-facing hemisphere is constantly monitored by a fleet of satellites, including SOHO and Stereo, and nearly all regions have overlapping coverage. If something major erupted, someone would have seen it. Instead, researchers had to dig through indirect data. There were no real-time alerts, no space weather warnings, only faint magnetospheric ripples in hindsight. This was a blind spot, and that's where the fear began to spread. If a CME this powerful could go undetected, how many others have? How many more might be coming, not just for interstellar objects, but for Earth itself?
It's easier for me to think this is a new kind of object that requires way more study than we've given it thus far.
You see, most of our solar weather detection systems rely on two things: light and magnetic signals. But if it is launched in a way that hides or warps those signals, like from the solar limb, or masked by another ejection, it could bypass early detection completely. That appears to be what happened here. Scientists now believe the 3I Atlas rode behind a larger, more obvious eruption, like a second bullet fired through the same hole. The first coronal mass ejection may have distracted sensors. The second came in hotter, faster, and hit the comet squarely. This is called a stealth CME. It's rare, but not unheard of. The issue is that most models don't predict them well, and they're incredibly difficult to detect without full 360-degree solar monitoring, something we still don't have. Which brings us back to the bigger problem. We are not prepared. NASA, ESA, and other agencies have made huge progress in planetary defense. We can track thousands of near-Earth objects. We have asteroid redirect missions. We monitor the sun constantly. But even with all of that, this coronal mass ejection got through, and it struck an object no one expected to be part of the story. 3I Atlas was supposed to be a one-way observation, a rare, fast-moving alien visitor, cataloged and watched as it passed by. But now it's the center of a mystery no one saw coming. The fear isn't that 3I Atlas was targeted, or that it's some kind of omen. The fear is what it revealed, the gap in our detection systems, the false sense of control we thought we had, and the terrifying reality that our sun can launch massive, damaging energy with zero warning. There's also the issue of how interstellar objects might interact with solar weather. We've never observed one this closely during a solar maximum. What if objects like 3I Atlas are more reactive than we thought? Some theories suggest that interstellar objects might carry magnetic fields from their home systems. That would change how they respond to plasma impacts. Instead of absorbing energy evenly like local comets, they might resonate, redirect, or amplify it, turning a simple solar hit into a chaotic internal event. This wasn't a controlled lab experiment. It happened hundreds of millions of miles away, live, with only fragments of data and no backup plan. It's like watching someone plug an alien device into a power outlet, only for the building to flicker. You saw the spark, but you have no idea what just got activated. The search for answers. Within hours of the hit on 3I Atlas, the scramble for answers began. Dozens of observatories, from Chile to Japan, shifted focus.
3I Atlas comes back into view. Right now, it is hidden behind the sun, and even during its closest approach,
Probes were retasked. Deep space antennas were flooded with priority requests. What happened out there? And more urgently, what does it mean? The collision was unusual and silent. There was no warning burst of radiation or bright flare, just a spike in energy and a comet that began unraveling in ways no one expected. That silence left scientists with only one tool left: forensic science. Think of it like a space crime scene. The object is still moving, the evidence is spreading across millions of miles, and the only way to reconstruct what happened is by pulling together tiny signals scattered across different wavelengths: optical, infrared, magnetic, and radio. The first theory on the table was natural. Maybe the comet hit a pocket of solar plasma that simply overwhelmed it. That would make this an accident, not an attack. But that theory started breaking down when the spectral data came in. In the hours after the impact, the tail of 3I Atlas changed drastically. It pulsed, it brightened, then it scattered into multiple threads, each glowing in slightly different colors. That meant chemical reactions were taking place, rapidly and unevenly. Cometary scientists immediately flagged this. A normal CME hit shouldn't create that kind of tail breakup, not unless the object was full of extremely reactive material. So now the theory changed. Maybe 3I Atlas wasn't just from another star system. Maybe it was carrying chemistry we've never seen before. A team from ESA suggested that some of the tail particles might be producing low-level magnetic fields. If that's true, it would be the first known comet to do so, and if the tail is magnetized, even temporarily, it could explain the strange scattering pattern, plasma reacting not just with ice and dust, but with magnetic resistance. A research group in Hawaii also reported that their telescopes had captured a short burst of infrared energy after the impact. Not before, not during, after, like a second phase. Whatever hit 3I Atlas may have caused a delayed chemical burn or energetic release inside the comet's core, and that brought up a deeply uncomfortable possibility. What if 3I Atlas wasn't finished reacting, and it's the impact only started something? A chain reaction we still don't understand. NASA hasn't confirmed that theory, but they also haven't ruled it out. Meanwhile, other scientists are digging into older data. Some of them now believe the comet's brightness began fluctuating days before the hit. Not enough to raise alarms, but definitely enough, in hindsight, to suggest something strange was brewing inside it. Even more chilling is the theory that this wasn't a one-time event. If the outer shell of 3I Atlas has already cracked, it could continue reacting to solar heat and pressure as it moves deeper into the inner solar system. That means more fragments, more gas, maybe even more mini outbursts. No one knows how many pieces the object has broken into. No one's sure how large or fast those fragments are moving, and no one can fully model what's coming next. As of now, nearly every major space agency has turned instruments toward 3I Atlas. The Deep Space Network is running simulations daily. New observations are coming in every few hours. But we're still in the dark on the core question. That's why the search is so intense, because scientists are trying to understand the depths of what's possible. A door we didn't mean to open. The comet is still moving, even after everything it's been through. The violent solar hit, the breakup of its tail, the chemical flashes. 3I Atlas continues on its path, but it's not the same object anymore. And neither are we.
We have on Earth and in space to get as much data as possible about this mysterious object.
Scientists around the world are watching 3I Atlas like it's a loaded weapon drifting silently across the sky. Telescopes continue scanning for changes. Probes are racing to catch just a glimpse of what it's becoming. We weren't supposed to get a direct collision between a coronal mass ejection and an interstellar object. We weren't supposed to witness an energy spike strong enough to rip apart a comet half a mile wide. And we certainly weren't supposed to have gaps in our system so wide that something like this could hit us without a single warning flash. But all of that happened. If 3I Atlas really is holding something reactive inside, something that behaves differently than any comet or asteroid we've studied, then this isn't just a freak incident. This is a natural experiment we didn't mean to start, and it's still running.